Good morning, dear student. Myself Amit Kumar Singh. Today we are discuss about the binary search. Okay, and this topic is in the subject of the designing analysis and algorithm. Okay. Before starting the topic, binary search, uh, the binary search is depend upon the some strategy. This strategy is called divide and conquer method. This method is briefly discussed in last video lectures. So in this lecture we will discuss only what about binary search and binary search algorithms and all these, and we will discuss about a example and understand about the binary search. Okay, so before starting uh, I will remember you that what is the divide and conquer method. Okay, basically divide and conquer method is a method which is well-known algorithm strategy. This strategy is discussed in my last videos. Divide and conquer approach, and divide and conquer algorithm works by the recursive breaking down of the problem. That means we have to break our problem in small problems, and these sub problem uh, are and after finding the solution we have to merge these problems. That means a divide and conquer algorithms by recursively breaking down problem into more sub problems of the same or related type, until these becomes a simple. And means we have to break our problem in sub problem. These is divided in another sub problem, at which time we have this problem when becomes a simple enough to solve directly. That means if a given complex, then we have to divide again and finding a smallest problem we solve directly. Okay, and after dividing the problem, and the solution of sub problem are combined. Okay, after solving the sub problem we have to combine and find the your solution. That means we go for the solution of original problem. This is basically fundamental discussion about the divide and conquer. And we start what is the binary search tree and what is the benefits about the binary search tree and so on. Okay, so first we have to start as a introduction part. We have to start. Okay, we will start what is the binary search and algorithm. We are know that what is the binary search, what is search tree and all other things. So first of all we have to say binary search is a search that find the position of a target value within a sorted array. That means if you are want to uh, search any value in array, that means first he have in a sorted array, then we have to find the position of target value. Okay, and in binary search is also known as a half interval search or logarithmic search. Why we have to call half interval search? Because of that we have when we have to discuss about the algorithm, then we will discuss why we are called half interval search. Because of that we have to divide our given array into parts like lower index to higher index between two part, this is called middle index value, and then further divide, and then how to discuss about the algorithm. So next in, so in a binary search algorithm work on the principle of divide and conquer method. Okay, this is a problem about the divide and conquer approach. Okay, and binary search can be limited on only shorted list of the element. Okay, that means it is fixed down, that means your given array is in the shorted order. Okay, it is if it is not shorted order, then we have to not apply the binary search. Okay, so we have to start the understand about the algorithm. That means its algorithm, which type of input will take. That means we have to goes for the binary search tree. Okay, binary search on binary search which, that means a given shorted array. So first input is that your shorted array. Okay, and have some size. Okay, then we have to denote the size of array just like a n, and shorted array, that is indicate to the a, capital A. And if we have to want a value, then the value is called just like a key. Okay, then we have to denoted that to be sure, that is called key. Okay, so in a binary search tree, three inputs are there. Okay, one is array, that is sorted array, this is a and array of size. Okay, and key, which value, that is that to search. Okay, so we have to start the binary search binary search algorithm. That is three inputs are there, a and first in this binary search algorithm approach is that we have to set the lower index and set the higher index value. That means we have to set, one is set lower, start with 1, or if you want to start with 0, then you have to say start with the 0. Okay, then I am here starting with the lower index value, that is okay, and higher index is, that is on the n, because of that array is n. And then we have to before applying the approach of binary search, we have to check, that is condition, lower is less than higher or not. That means if lower is equal to higher, that means one value. If lower is greater than higher, that is not possible. Okay, so first we have to check according to while condition, lower is less than higher. Okay, then after that, if it is correct, then set the value of middle value. And how to find the middle value? That means we have to find mid value is equal to lower plus higher index value divided by 2. That means we have to first divide our sub problem. Okay, and after finding the mid value, we have to check our number is less than mid or greater than mid. If it is less than mid or equal to, if your search value is equal to mid, that means you have to find your value. Okay, if the key value is less than mid, that means we go for the left hand side to be search, and left the, that means I have dropped the idea according to right hand side, otherwise vice versa. Okay, so then we have to check the condition. If, that means we have to check our condition. What is this? If our we have to say our key is equal to a of mid. That means I'm telling you, if your search value is equal to array mid. Okay, that means if mid is just we have to write a array, just one is this one. Okay, the value is 2 4 6 8 9. Okay, 2 4 6 8, it is short array, and index is 1 2 3 4 and 5. Okay, this is, and first you have to find the mid. Then what is the mid equal to 5 plus 1, this is equal to 6. Okay, this is 5 plus 1, this is 6, divided by 2, this is 3, that is mid is 3. Okay, if I have to see here the third value, that means he will say this is if our key is, if key is equal to 6, then what he will reflect, if key that is 6, that is 6 equal to a of mid equal to 3, so a of 3 is equal to 6. Okay, this is equal to this, that means return the value of mid, uh, uh, and we will find the our search value. Okay, if it is not clear, that means if your key value is 4, okay, then what we do, we for goes for else condition. Okay, else if condition, if else if, that means you have to say else if key is less than a of mid. Okay, key value is 4, a of mid equal to a of mid equal to 6, that is okay. Because of that, this value is 6, this value, if I am writing here, this value is 6 and key is 4. Okay, this is right. Okay, set the high equal to mid. Okay, then set a high equal to, that means this high is set to the mid, that means here. Okay, that is okay, and set, otherwise else set the low equal to mid and end. If that means we have to repeat this condition, and after that we have to find the condition, and if we have to not find if it is lesser, that is 4 is lesser, then we have to search only in this sub array, and we have to left this sub array. Okay, so this is approach to solve the problem of binary search. Okay, and in the binary search we have to see here all the things are based on the divide and conquer method. Okay, so let me start some example to understand our algorithm easily. Okay, so we have to take example, and just like we have take first example, the array is 1 3 5 and 9 and so on 21. This the first if you have see that data 1, that is called array name, and this value is in the shorted array. Okay, and then second data 2, this is also shorted one, data 3, this is also shorted one, and in the first array we have to find the value 15, and the second one is find the value of 4, and the third one is find the value of 33. That means we have to consider three examples and three type of examples. Okay, that is 15, that is greater than value, that means they will on go for right hand, left hand, and then again right hand. Okay, so let me start. First array is there 1 3 5 7 9 11 13. Okay, 13 15 17 19 and 21. That means first we have to set the low and high. That means on the left side this is low and the right side this is high. Okay, then first set low, and then second we have set high. Okay, and after that according to algorithm we will find the mid value. Okay, so in the value reach for 15, the value is middle index array is 11, that means middle. Because of that I'm not writing here about the index, then you have to write 1 2 3 4 5 6 7 8 9 10 and 11, and 11 plus 1, this is equal to 12, divided by 2, that is 6 position, that is 11, and here I am writing here array is 11, and is value 11 is first value he checked, the is called 15. 15 is equal to 11. That is not right. That means this condition is false. Okay, and after that he check the value of key is greater or lesser than 15 is greater than 11. That means we have to check in this sub array. Okay, and we have to left this sub array id. Okay, so according to this, I'm discussing about it. Okay, so mid, after finding the mid, if the value search is greater than the value, the middle index array, okay, if greater than this, that means middle index value is less than your key value, okay, then search the continuous at the right hand side. That means after middle we have to check, we have to search our uh, key value. Okay, so in this step, at each step the middle index change according to direction of search. That is right. Okay, and then second, at next step lower index, that is on the one, change to the previous middle index. That means he goes for the index 6, that value is 11, and this is because searching continuous from middle to high. Okay, okay, it is right. And what is the meaning? The next high index is 11, that is change will be also cause the middle index, that is 15, to be changed. Okay, that means we have to finding the 11 to 12. Okay, 11 to 12, and sorry, 11 to 21. Okay, so in this condition, if you are writing from here, this is the 6. Okay, okay, I'm writing here, this is the 6, this one is 7, 8, 9, 10 and 11. That means we have to 11 plus sorry, 11 plus 6, this is 11, this is 6, divided by 2. 11 and what is the value of 11 plus 6? This is equal to 17, and 17 divided by 2, that means 16 point sorry, 8 point something. That means we have to take floor function, this is equal to 8. Okay, that means next middle is 8. Okay, and then what we will check here, we have to check uh, according to algorithm, to search for 15, we have to search 15, and then check what is check, the value is, sorry, the value is, that means we have to check, uh, we have to check the index value is equivalent to, yes, there is middle value is 15, middle index value is 15. What you will search? Okay, what you have to search, that is also 15, that is equivalent, that is stop the algorithm and finding your values. Okay, then this one is we will find, that is okay. So the search 15 is found it, that means the second step we have to find. Okay, and next step goes for next question. The value is searching here, what value we will search here, I I will tell you, we have to search in this array 4. Okay, we have to our that means we have to say your key value is, your key is equal to 4. I will search it 4, and first what we do, that means we have to set your lower and then higher. Okay, and then finding the middle value. How to find? This is 1, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Here also same, this is equal to 12 divided by 2, that means 6, that is here, this is mid. Okay, this is mid, mid equal to 6. That means first he check mid value is equivalent to the key value. Mid is 16 and key is 4. That is equivalent? No. Then check key is less than or greater than mid. Then after checking the value, we will find the key is less than mid. That means we have to search left hand side of the sub array and we have to drop this sub array. Okay, so here we will start. First we have set lower index and then set higher index, and after that we have to check this is middle value or not. That is false because that 4 is not equal to 16. This is false. And 4 is greater than 11. No, this is also false. That means we have not goes for right hand side, we have to go as a left hand side. Okay, so the value search is less than the value of middle index. I have to search continuous in the left hand side from the middle value. Okay, so in this what type of step used? At each step the middle index change according to direction of search. That is okay. And next we will say that at next step higher index, that is called 30, to the previous middle index. That means higher index is goes on the mid value. The value is set is okay. That is because searching continuous from lower to mid value. So that means next higher value index is 6, changes the cause of next middle value is 7. And here we have to check that means 16 our mid, then higher is mid. That means what we will say, that is higher and this is lower. Okay, high lower is on 1 and higher is on 6. Okay, this is sixth position divided by 2, this is 7. That means 3.5. that means lower floor function is taking, this is third value, this is first, second, third. That means third is middle. Okay, third is middle. Then what he will check, that is he check 4 is equivalent to 7. This is not, that means mid is not equal to key value. Then he check 4 is greater than 7 or less than 7. Then he will check it is less than 7. That means we are continuous searching from left hand side again. So we have to write here our conditions. Okay, and lower and higher, and then finding the our index value here. Okay, and after that we will find 4 is greater than 7. No, 4 is less than 7. That means we have to search in the left hand side. Okay, middle of left. That means again some step same steps are repeating. At each step middle index change according to direction. That means we will go for again left hand side. Okay, and next higher index is 16 is shifted to the middle, that is 7. Okay, middle, that is 7. And because of that we have to search the key value in the left hand side. Okay, so we have to next higher is 7, and then finding the new middle. That means we have to say this is lower and this is higher, and 1 2 3, that means 1 plus 3, this is equal to 4 divided by 2 is this, and this is middle. And he will check middle value is 4 is equivalent to the key value. K is also 4. That is okay. He will say we will find the value, and to stop here our algorithm, and we have to find this is 4 value because of this is lower and 7 is higher, and the middle value is finding here. Because of that we have to check plus higher here. Okay, and here discussion stop our discussion according to algorithm. Okay, and we have to our value 4. Okay, in the middle value. So second is stop here, and next example we will find the value is 33. Okay, so in this example we have to find the value that is called 33. So how to find 33? Same procedure of here. Okay, and what is the procedure? That means we have to lower and higher. Okay, same, this is lower and this is higher. Okay, and lower is 1 and higher is 2, 3, 4, 5, 6, 7, 8, 9, 10. That means 1 plus 10. Okay, divided by 2. Here divided by 2, that means 11, that means 5 point something. That is the index value, middle value is 5. Then 1, 2, 3, 4, 5, this is 17. This is middle value. Okay, and sometime here we have to change our theory. Not if you are not interested in sorry, floor function and ceiling function, then we have to also say this is lower, this is higher, and after middle we have to check the middle is 17 is equivalent to 33. This is not, and 33 is greater than, this is true. That means we have to check our from mid to, we have to check from middle to, that means 17 to 37. We have to check where is our key value. And here the flow, if you are not checking about the greater or lesser floor and ceiling function, then you have to apply this type of theory for an even number of array, then n by 2, then n minus 1, and because and n minus 1. Because of that, here if we have to start from 1 and goes to 10, this is even number, then divided by 2, that means n is 10, that means divided by 2, this is 5, and on again 11, total is 11. Okay, total is 11 and divided by 2 and minus 1, this is equal to 10 by 2, this is 4. Okay, we have not applied this type of theory. We have apply only our floor function. This is right from you. So we check our middle index and change the direction. Same, the lower is the is here we have to check mid to high. That means your lower goes on the mid. Okay, goes on the mid. That means your mid on 17, that is index value. So 5 to 10, that means 5 plus 10, that is 15, divided by this, and I will find next index value. Okay, and same we have to check here, and that is 17 and 37, and after that we have to find the lower and higher, divided by 2. That means this is position 5, this is position 6, 7, 8, 9, 10. That means 7 point something, that means seventh value. Seventh value is 25, then 25 is our middle value, and after check and our key value, that is 33, this is not. Okay, so we will check 33 is greater than 25. Yes, then we have same step follow. That means we have goes for finding our key value, that is 33, that is this value is belongs to high. That means we have to check with 25 to 37 and finding our value. Then on the 7, that means your lower goes on, that is 7, and higher is fixed. Then 7 plus 10. Okay, and we have to repeat all these steps. You have to well known understand about this. Then after plus okay, I am writing here, this is our lower, this is our higher, this is 7, this is 10, this is 17. 17 divided by 2, that means, okay, that means our middle is on 8, that is this one, this is our middle. Then again check our middle is equal to 3, this is not. Okay, our mid value, that is called 29, is less than 33, that means greater than 29. Yes, then again we have to check mid to high. Then mid is 8 and high, this is again 18. 18 divided by this is 9, and then mid goes on to ninth position. That is, we have to check 33, that is mid value, is equivalent to key value. This is also key value is 33, that is okay, and done our solution. So same step are follow there, and we have to say all these steps have to repeat here and finding the our value. Okay, and again we have to search, and again middle index value change the according to direction, and next step lower goes to again sorry, lower goes to on the middle value, and higher is fixed. So after this step we have to find our mid value, that is 33, and our key value, that is also 33. That means we have to stop here, and we have to say our key our result is 33. That is finding after 4 steps we will go for subdivide our problems. Okay, so again uh, we have to discuss uh, next point about the algorithm, and another things in last our recursion problem. We have to discuss the uh, asymptotic, when we have to discuss asymptotic notation and master theorem and recursion. We have to discuss about the complexity of binary search algorithm. If you have to not seeing my video, then we you go on my previous video, that is based on recurrence relation and substitution method. In this method I am discussing about the I am talking about the complexity of our binary search algorithm. Okay, so we have to say thanks before thank you. I am saying that we have to discuss next topic about the merge sort. Okay, so in next topic we will discuss about the merge sort. So I am just telling about the merge sort. That means because why we are discussing in next video lecture to the merge sort, because it's also depend upon divide and conquer approach, which are discussed again and again. What is the divide and conquer method, and uh, because of that we know that divide and conquer method have properly 3 steps. That means you divide your problem in sub problem in a small problem, and after finding sub problem we have to solve these sub problems in recursive steps, and after that come solution and find the main problem solution. The merge sort basically it have depend upon only 2 type of principle, and then we have to say these principle. That means sorting smaller list is faster than storing large list. Okay, this is also sorting a smaller list, and that is faster than sorting list. Okay, and combining 2 sorted sub list and then 2 unsorted list. Okay, these are the 2 principles behind the merge sort, and merge sort is also just like it's also depend upon divide and conquer method, and basically short is more faster sorting regarding to binary search and linear search, because if you are seeing my regression video, then you have to know the complexity and what is the complexity of our binary search, and what about the merge sort complexity. you have to see the merge sort complexity is n log base 2 of n, and in a binary search we have to find n square. So the complexity of merge sort is much better than linear search and binary search. So in next video we have to discuss merge sort briefly, and thank you.